Final are going to be from this section. 8.3. The last section that we're going to cover. Okay. So there you are. We want to solve non-homogeneous system. Solving. Okay, non-homogeneous. Okay, non-homogeneous linear system. Okay, linear system, the system of differential equation. See? So let's see what's going to be the general form of the non-homogeneous. So consider the following system. Okay, consider the following system of differential equation. System of differential equations. Okay, this is it. The equation is, the first part is like the one that we did before. Dx dt is going to be equal to the ax plus by. So that's homogeneous. But there is going to be an extra function. We call it f1 of t. That function, okay. The second equation is going to be dy dt. So as we did it before, it's going to be cx plus dy, an extra term, a function of t that we call it f2 of t. Okay, nothing to do with the derivative. It's just two functions. Okay, this is going to be, okay, so this is going to be non-homogeneous. So it is non-homogeneous. It's going to be non-homogeneous linear system. Linear system. Okay, now we change it to the matrix form quickly. Okay, with the following matrix. Following matrix form. So the matrix form for the homogeneous is the same thing that we did before. We call it x prime. Okay, that's it. Remember, x prime equal to the a times x. That is the homogeneous part. Now we have a new term. So the new term will be denoted by f of t. F of t, then introduce these where a is the matrix of the coefficient. Okay, it's going to be A, B, C, D. And f of t is going to be a column vector. Okay. And your column vector are going to be f1 of t. And this is going to be f2 of t. Okay, this is it. So we change it quickly into the linear system that we're going to have. Okay. Now we want to solve it as usual. We consider the complementary, okay, or associated homogeneous system, x prime of ax. We solve it, we find the general solution, we call it xc. Then we are going to find a particular solution, we call it xp, and the xc plus xp is going to be the solution of the equation. Okay, so the complementary or associated. Okay, that's it. The complementary homogeneous system. Homogeneous system is going to be, okay, this is it, x prime equal to the a of x. This can be solved, okay, and can be solved to find the solution, okay? To get what? To get the solution that we call it x of, we got the x of c. Remember, x of c is going to be c1 x1 plus c2 x2. So that would be the general solution of the homogeneous one. And we solve it as we did it before. So this is going to be, to get this one as the general solution, Okay, general solution of that homogeneous part, okay, that we talk about it. Now we have to introduce a particular solution. So there you are, if XP, we call it. XP is going to be a particular solution, is a particular solution of that system, okay, of the system. Okay, the system, original one, of the system that we have. So this is going to be that X prime equal to the AX plus, okay, F of T. Okay, if this is going to be the case, then we have a solution. Then X equal to the XC plus XP is going to be the general solution of the system. Okay, is the general solution. General solution, okay, of the given system. Of the given system. So that's a roadmap, if you like. Exactly as you did it for the, okay, for the linear equations. Now the question is, how are we going to find the XP? In order to get the XP, two different methods. Undetermined coefficient and the method of the variation of the parameter. Okay, so in order to get there, exactly as you did it before. Okay, that's it. To find the XP, one can apply those two methods that talk about it, undetermined. Okay, this is it. We can apply that undetermined that we did before. Okay, undetermined coefficients. The coefficients or variation of the parameter. Variation of the parameters. Okay, of the parameter method. There you are. So we do the undetermined coefficient first, okay? Because that would be straightforward. Then we come back and we do the okay. Any question? The first one. We wanted to solve this system. Okay, solve the system or use the method. This method is really clear. This group solve the system. The system is going to be this one. We have X prime equal to -1, 2, -1, -1, 1, X. And this, the function is a constant function, -8 and 3, it's just a vector. This is the easiest case for the undetermined coefficient. Okay, there you are, you know that. Solve the homogeneous one first. So solution, we're going to solve this system first. The system is, that's it, X prime equal to the -1, 2, -1, 1 times X. Solve this one first. You know the idea, I just go ahead and just do it. You have to find the eigenvalues of the, okay, of the matrix. So we work on the determinant of the A minus lambda I, which is going to be the determinant of this matrix, -1 minus lambda 2, -1 and 1 minus lambda. Cross multiply to get the determinant. So it's going to be -1 minus lambda times 1 minus lambda minus 2 times the -1 would be -2, but there's a negative here, 2. Okay, this is going to be the case. So you can FOIL it. We can multiply, pull out the negative sign. It's going to be 1 minus lambda square, but you can, FOIL it. So it's going to be -1 plus lambda. Okay, that's it, -1 plus lambda, and this is give you -1 minus lambda. Yeah, it's going to be -1 and plus lambda, and then we multiply this one. Get the what is wrong with this? Okay, they will cancel out. Okay, that's right. So, and this is going to be plus lambda squared. Okay, lambda squared plus 2, you let it equal to 0. So combine them together, that give it -1 plus lambda squared. Plus 2 equal to 0, that give you lambda squared. Okay, lambda squared plus 1 equal to 0. So we get the lambda squared equal to the -1, you call it I squared. So lambda would be positive -I. So the solution are complex. It can be, either of those solutions that we have. It doesn't matter. Okay, you know that for the complex solution, you just pick one of them. You pick the lambda to be equal to the I. So this would be 0 plus 1I. You call it alpha plus beta I. Make a note that the alpha is equal to 0 and beta is equal to 1. End of the problem. Okay, and you have to go back and find the k. So you form A minus the lambda I times k equal to the 0. Go to the matrix and you replace the lambda by I. So you have a matrix and it's going to be -1 minus I 2. Okay, -1 minus I 2, and this is going to be a -1, and then you have 1 minus I times it by K1, K2 equal to the 0, 0. Just work on one of them would be enough. Okay, to get this one through, just multiply the first one. It's going to be -1 minus I times K1. Okay, times K1 plus 2K2. That's 2K2 equal to the 0. Okay, then you can pick on one number for one of them and find the other one. Okay, so it doesn't matter which one you want to take. Okay, if you want to avoid rationalize realizing, if you like, you call k equal to 1, for example, then that give you -1 minus I plus 2K2 equal to the 0. So this would give you 2K2 equal to the -1 minus I. So your K2 would be -½ Okay, -½ minus -½ I. So this would be your, okay, it's going to be your K2. So you have to form K, you know that. Then you have to change it to the V1 and the V2. Any question? So I go to the next page, continue. So K1 is 1, K2 is -1, -½ I. So this is going to be, yes.
On the previous page, it looks like you just had K equal nothing and then a box. Can you explain that? Is it a different color? Box, lower. Is at the very bottom, bottom corner, under where the K's are.
K is equal to 1. I just since I
Is that K1?
K1, yeah, it's K. K1 is equal to K. Okay. K1 is equal to 1 and K2 is -½ minus I.
Wouldn't the -1 and -I change signs? Wouldn't it be 1 plus I on the other side when you move it over?
Okay. You are right.
All right. Thank you.
Okay, are you ready? So introduce the K. So that would be, your K is equal to the K1. So that was 1. And that's a 1/2 plus 1/2 I. Okay, you know that you have to break it. You break it to the real part. It's going to be 1, 1/2. And the complex part. Okay, the complex part of the first one is going to be 0. And the second one would be 1/2. This is going to be your B plus, okay, BI. B1 and the B2I. Okay. The number that I use in my notes are do it the other way around, I know you arrive at the same number eventually. Okay, there you are, and now we are ready to give you the solution. Remember, we already talked about the alpha is equal to 0 and beta is equal to 1. So we are going to get the solution, which is going to be x1. Okay, remember the x1 was what? X1 was, just remind you, b1 cosine of the beta t minus b2 sine of the beta t. There was times e to the alpha t. That seems alpha is 0. So that gives you simply your b1 is 1/2 cosine of the t, and minus b2 is 0/1/2 sine of the t. Okay, so that would be your x1. And for x2, you switch it. Okay, for the x2, this is going to be b2. We can switch this one or the other way around. Both of them give the same one. So that gives you cosine of the beta t and minus the b pi plus the b1 sine of the beta t. The other way around. So when you substitute, so that gives you b2 is going to be 0/2 times cosine of the t plus plus b1, which is going to be 1 and 1/2 sine of the t. Okay, so these are going to be your x1 and x2, and simply xc this time. It's going to be c1 x1, okay, c1 x1 plus c2 x2. You keep this one as is, and because you're not going to use this one, and you go and find the, okay, you go and find the xp. Okay, any question? So this part is like the previous part. It's a complex solution, doesn't matter. Okay, so the next part is going to be what's going to be xp. Get the solution. So you bring the function, extra function that you have. Remember, your f of t is just a constant vector. You see, that's going to be a constant vector. As we did it, so it's a constant polynomial. Remember when we did undetermined coefficient, it's a constant polynomial. We changed these components, these coefficients, into the two unknown, a1 and a2, for example. Okay, so what we are going to do is suggest that the xp to be equal to the, okay, a1 and the b1. Use the lowercase letters because we have a matrix A. You don't want to be confused with the a1 and the a2. But you can use any, anything you like. Okay, so depends on what you have for the function. Okay, in this case, they are both constant. So you're going to pick two constant, and then you have to go and find what is going to be a1 and a2. Now, you know that this should satisfy this condition in the theorem. So if you substitute in the equation, so the equation would be x prime of p is equal to the a times x of p plus f of t. This is where you're going to put it to get the, okay, to get your a1 and a2. So x prime of p, you just differentiate the component. Okay, so x prime of t in this case is going to be simply 0, 0. So substitute here and then solve for the unknown that you have. Okay, if it's going to be exponential function, sine function, you differentiate. We already talked about it. If you have a matrix, it's going to be derivative of the, okay, their component. So bring it here. So this would change into the 0, 0. You have to write on the matrix form. Okay, 0, 0. And your A was what? -1, 2. And the -1, 1. That is A times it by XP. XP is A1, B1. Okay, plus F of T. F of T is -8, 3. You have to simplify this matrix, okay, then use the condition for the equality of two matrices. Two matrices are going to be equal to each other if they, okay, corresponding components are the same. Then eventually you end up with the system of the equation. You'll be able to solve that system to get the A1 and A2, okay? So we have to work on this to simplify this one. So it's going to be 0, 0, multiply, instead of the matrix, So that gives you negative A1 plus 2B1. And if you multiply the second one, the dot product, so that gives you negative A1 plus B. Okay, this is the multiplication of these two matrices. And extra one is negative 8 and 3. Now add the components. So that gives you 0, 0, corresponding entries, if you like. So this is going to be negative A1 plus 2B1 minus 8. And the second part would be negative A1 plus B1 plus 3. Okay, you end up with this. Now you let the corresponding entries to be equal to each other to give you a system of equation, and so for A1 and A2. So this is it. So the first part over here, you have negative A1 plus 2B1 minus 8 equal to the 0. And for the second one, we have a negative A1 plus B1, okay, plus 3. See? Solve this system of the equation by addition method. You can multiply the second one by a negative sign to eliminate the A1. So we multiply the second one by negative 1, so to make this one to positive, negative, negative. So these two will cancel out. So the leftover is going to be plus B1. That give me negative 8 and negative 3 would be negative 11. So that give you the fact that the B1 is equal to the 11. That's a B1. Go back and substitute in this equation. In one of those equations to give you the, okay, to give you A1. So if you substitute the first or the second, doesn't matter. You substitute the second one, so that give you negative A1 plus 11 plus 3 equal to the 0. 3 and 11 would be 14, so A1 would be 14. So you have it. So what's going to be your XP? XP is going to be A1 is 14, B1 is 11. Okay, this is one particular solution. Then you add them together, and you declare the solution of the system. Any question? So, it's a straightforward. Sometimes getting messy, depends on the system that you have to solve. But it's always, easy problem to do. So we declare the final answer. Okay, this is it. The final answer, we just rewrite it, we accept it. Even if you want to list it, you can do it. Depends. If you have kind of initial condition at the end, then you have to give us the system in full format. So this is it. So the final answer, x of t, is going to be x of c of t plus, x of p, if you like. This is it. So you can bring those a solution and be accepted. So officially, this is it. It's going to be C1 x1 plus C2 x2 plus xp. Accepted, you can repeat it, but you're not going to get anything. But if you have initial condition, you have to list it and then put them together. Okay, that's case 1. Any question? I give you one linear one at least, okay, to see, because if it's not going to be constant, there are a couple of points that you have to consider when you want to solve that last system. So, this is the most that we have. You have a quadratic one also in one of the problem in your book. I think I put that one in your practice one probably. Okay, everyone got the idea. So this is it. Yes, what's the question?
Is there any way that you would know which method is easy to
Of
use?
course, exactly what you did for the equations. For the linear equation, the method can be applied to the polynomial, sine function, cosine function, exponential function. It's the same thing. Now, those are going to be very tricky, especially if you have a kind of repeated solutions. So my suggestion is for the polynomials, use this one. Anything else, variation of the problem. Because you will get involved in such a method that's such a messy techniques. You can try it. When there is a repeated solution, it's going to be. So the suggestion is this: polynomials. Use the undetermined coefficients. Anything else, variation of parameter. You can use variation parameter all the time. But on the test, we may give you the instruction. Okay, instruction will be given to you, then you'll be able to know. You have to follow the instruction. But you have no other choice. You can try. You can try one of these easy exponential one. See what would happen if you use the variation of, undetermined coefficient. Let's just try this one, you will see it. Maybe get something like that. Okay, but generally that's it, as you did that. Whatever we did before, you are going to do the same thing here, okay? So look at this one. That was a constant function. Let's have a linear function. So the next example is going to be this one. Solve the system. Solve the system. Okay, so this is the system this time. We have a dx dt is equal to the 6x plus y plus 6t. Okay, and the other one is dy dt. dy dt is 4x plus 3y minus 10t plus 4. See this system? Your function is just a linear function. Okay, you may have a linear or you have quadratic for this group. It's going to be higher than it would be. Takes quite a while to do. Okay, there we go. Go for it. So solve just change it so that you can have your f of t, etc. Okay, solution. So this is going to be the system. When you change it to the matrix form, it's going to be x prime, and you have the 6, 1, 4, 3, x. Now the function matrix is going to be, so the first component is 6t. Second component is a negative 10t plus 4. See, this is going to be your function. Okay, so as we talk about it, this is going to be your a. Okay, and this is going to be your f of t. So we have to solve the homogeneous one first. Okay, so we go for the homogeneous part. So we form the x prime equal to the 6, 1, 4, 3 times x, and we look for the xc. Solution of the homogeneous one. Get the matrix as we talked about it before. Let's see what type of eigenvalues are going to have. So we form the determinant of the, determinant of the a minus lambda I is equal to, it's going to be 6 minus lambda, 6 minus lambda 1, you get a 4, 3 minus lambda. Okay, cross multiply to get the determinant of this matrix. So that gives you 6 minus lambda times 3 minus lambda minus 1 times 4, 4. Okay, carefully FOIL it. So that gives you 18 minus 6 lambda minus 3 lambda plus lambda square minus 4. Okay, combine the like terms. So that gives you lambda squared minus 9 lambda and plus 14. Plus 14, you let it equal to 0. Easy equation to solve. Okay, so you factor it into the lambda minus 7 times lambda minus 2 equal to 0. So you have two distinct solutions then. Okay, we get the lambda 1, it doesn't matter, lambda 1 equal to 7, and the lambda 2 equal to 2. Okay, now work on the eigenvectors. Okay, we go with the lambda 1 equal to 7, and we form the matrix of A minus lambda I times K equal to 0. So go to the matrix over here, replace the lambda by 7. So you end up with 6 minus 7, 1, and that would be 4, 3 minus 7. K times it by K1, K2 equal to the 0, 0. To simplify it, that give you negative 1, 1. This part is going to be just 4, negative 4. Okay, that give you 4, negative 4 over here, and times the lambda 1, K1, K2, equal to the 0, 0, just economy dependent system. So just get the first row, which is going to be negative K1 plus K2 equal to the 0. The conclusion is that K1 is equal to K2. So consider both of them to be 1. So you have your first again. Okay, this is it. So K would be 1, 1. So K is 1, 1, and then you have the X1. Okay, your X1 is going to be 1, 1, e to the 70. So that's going to be your first particular solution of the homogeneous one. Okay, any question? Repeat it again. For lambda equal to 2. Okay, we go back and replace the lambda by 2, form that matrix to get the corresponding K. Are you done? So going to the finding the lambda 2. Yeah, that's good.
So K is equal to K1, K2, right?
Yes.
Okay.
Yes, because both of them are the same, so I call them 1.
Okay.
Okay. So go to do the same thing, lambda equal to 2. Okay, lambda equal to 2. This is the lambda 2 equal to 2. So we are going to with the A minus lambda I times the K equal to the 0. If you put the 2 in that format that we have, okay, so that gives us 6 minus lambda, 6 minus 2 and 1. And that was 4. And the 3 minus lambda, 3 minus 2. Okay, times the K1, K2, 0, 0. So simplify the first one, give you 4, 1. It's going to be 4, 1, and this is going to be 4, 1. As we expected, okay, they are always the same. So get the first one, which is the 4K1 plus K2 equal to the 0. Okay, you pick a number for K1, for example. So this is K2 would be negative 4K1. So pick the K1 will be equal to the 1, and the K2 will be equal to the negative 4. So the vector would be 1 and negative 4 this time. So we have our second solution, X2. X2 is 1 and negative 4, this time e to the 2t. So we are ready to give you the XC. So the XC is going to be C1 X1 plus C2 X2. So that's a solution to the homogeneous. Yes,
Why is it 2t? E to the 2t.
e to the lambda t.
Or the
Lambda
lambda.
Okay, now we are done with the homogeneous one. So what you have for the function and go for the for the yp. So we have to find the x of p. X of p. The function in question is, remember the function was what? The first component was 6t. The second component is negative 10t plus 4. You see, they are a polynomial of the first degree, linear form. You have to give us a complete linear form for your xp. So the suggestion is going to be xp is equal to, this is 60, you change it to the a1 plus a2t. And this is of the first degree again, so you change this one to the a3 plus a4t. Okay, so this is going to be your suggestion. If they are going to be quadratic, you have to write 2 quadratic ones. Okay, that's it. So that's a suggestion. You have to find A1, A2, A3, A4. You need 4 equations. So take the derivative of xp. If you differentiate it, that gives you A2 and A4. That's the derivative, okay? Now drop it into the equation. So the equation that we're going to use is going to be x prime of p is going to be a times x of p plus f of t. Okay, go and bring all those. We're done. Okay, x prime is, we have the a2, okay, the a2, a4. A2, a4 is equal to the matrix. Matrix 6, 1. Okay, 6, 1, 4, 3, that's your matrix. Your XP, this is your XP. Your XP is A1 plus A2T, and you have the A3 plus A4T. okay, and plus f of t. Your f of t is 6t minus 10t plus 4. See, that's the one. You have to simplify it, the term to the right. You combine them into one matrix, and you have one on the left. You let them equal to each other. Then you'll be able to find these components for us. Okay. So let's work on this. Carefully multiply it. So this is it. I have A2 and A4 here. It's going to be unchanged. Multiply. It's kind of dot product type. You multiply the 6 by this one, add it to the one of this. So that gives you 6A1 plus 6A2T. This is when you multiply the 6 by the first, then 1 by the other one. So it's going to be A3 and the A4T. That's the first row, okay? You multiply this row by this column, okay, as a dot product. Then you repeat it for the second one. 4 times the first one, which is going to be 4A1 plus 4A2T. And you multiply the second one by 3, so it's going to be plus 3A3 plus 3A4T. Okay, this is going to be the product of these two matrices, okay? We have an extra column vector, so which is a 6t, okay, the 6t minus 10t plus 4. Now combine them together. Okay, we're going to add it. So you have the A2, A4. A2, A4, and here is going to be the case. Okay, so I have to add it, and then I factor it. 6A1, 6, A2T, A3, A4T. Then you have an extra 6T here. Okay, and the second part is 4A1, 4A2T, plus 3A3, plus 3A4T, minus 10T plus 4. So this is what you get. You have to write this interest in polynomial forms because you want to let the coefficient to be equal to each other to get. Okay, so you have to factor out the t, you see. So this is going to be, you factor out the t, and then you just put the constant over there. Okay, so, and then you let them equal to each other. I'm going to do it at the same time. Okay, so I'm going to let the first entry over here equal to the A2, and the second one equal to the A4. Then it's going to be identity of two polynomials. Then you factor it out. You know that the coefficients of the monomial of the same degrees are going to be equal to each other. Eventually you get four equation. Okay, I'll go to the next page to do it. So I let these two be, okay, the entries will equal to each other, and start simplifying it. So this is it. So the matrix, the entry of the left one is, what was the left one? A2 and A4. Okay, so it's going to be, you get A2 equal to, okay, A2 equal to the one that I have. You see, I want to do the linear algebra at the same time. So what I'm going to do, you see the factor of the t here. Simplify it. You factor out the t, because eventually it's what we have to do. And so I have 3 terms to factor the t, and the constant term is 6A1 plus A3. So I start with the constant term, 6. Okay, that's going to be 6A1 plus. Okay, that's it. So 6, you get a 6A1 plus A3. That is the constant term, and the leftover. Factor out the t at the same time. Okay, factor out the t, you get A2. Okay, you get a 6A2. You get 6A2. That is the 6A2, A4, and 6. A4 and 6. This is times it by t. Okay, I didn't miss anything. We have all of them available. Okay, so this is the first one. In the second one, this is going to be A4 equal to, you do the same thing for this one. Okay, what's the constant term? So the constant term, we get 4A1, 3A3, 4A1, 3A3. There was a leftover of the 4 as well, plus 4. So that's going to be the constant term. Then factor out the t. So what you have, the coefficient of the t's. I have 4A2 plus 4A2 plus 3A4, and I think that's a negative 10. Yes, minus 10 times t. You see, this is what you get. Now you know that the polynomials are equal to each other if their corresponding coefficients are the same. So the constant term to the left is A2, to the right is this one. So you get one equation here, you get the 6A1 plus A3 equal to the A2. And the t, there is no t here, so the coefficient of the t is 0. And the coefficient of the t on the other side is 6A2 plus A4 plus 6 equal to the 0. This is what you get from the first one. Okay, the coefficient of the t. There's no t here. You can imagine that it's A2 plus 0 times t. Now, the same thing for the second one. In the second one, the constant term is 4A1 plus 3A3 plus 4 is equal to the A4. That's the constant term. And there is no t to the left, so the coefficient of the t must be 0. So 4A2 plus 3A4 minus 10 equal to the 0. There you are. You have a system of 4 equations, 4 variables. Then you have to solve this one and to get it, okay? So it's going to be a kind of a straightforward one. If you look at it, you see over here, let's see. So you have to, you have to eliminate one of them, couple of them to be able to put them together over here. Okay. So check to see if you can find an equation with 2 variables only. Okay. So look at this one. In this case, it's a 3 variables. You better leave this one. Don't try this. Okay. These 2 are not going to be good. But if you check these 2 here, you see, this is an equation in 2 unknown, A2 and A4. And this is the equation in 2 unknown, A2 and A4. You do these 2 first. Okay, so at least you find 2 unknown, you come back, you substitute, because the difficulty of this one is you have 3 unknown. You can do it. 3 unknown. Okay, so you have to find one of these unknown first. So it's always the case. You have to look to see which one is easier to handle first. Okay, so we're going to put these 2 together and solve the system. There you are. So this is going to be 6A2 plus A4 plus 6 equal to the 0. And over here you have 4A2. Okay, 4A2 plus 3A4 minus 10 equal to the 0. Use elimination method to solve this system. Okay. You can eliminate the A4 by multiplying the first one by a -3. This is one choice, okay? Or the easy choice. So multiply everything by -3 on the first one, -18, A2 minus 3A4 minus 18 equal to the 0. Keep the second one as is, okay? So it's going to be 4A2 plus 3A4 minus 10 equal to this. Now, if you add them together, the A4 would disappear. A4 would disappear, so that gives you -12 A2. Okay, -14, yes. -14 A2, -14 A2, and that would be -28 equal to the 0. Okay, so we find the A2, which is a -2. Okay, that's it. So we get the 14 A2 equal to the -28. So A2 would be -2. So this is the first one. Then you go back and substitute here to get A4. Okay, so this is it, A2 equal to the -2. Substitute in this, one of these equations, doesn't matter which one. Okay, to give the A2, I substitute the second one. So that give me, substitute here, that give me -8. That's 3A4 minus 10 equal to the 0. So that give me 3A4. 3A4 again minus 18 equal to the 0. So A4 would be 6. Okay, there you are. You have the two of these term. Now go back and use the other two equations. The leftover that we did have are the coming. So this is the one, A1 plus A3 equal to the A2. You already got the A2. And this is equal to the A4. You already got the A4. Then you can, you can solve these systems and you're done. Okay, so there you are, the next group. The next group, I'm going to use this one now. 6A1 plus A3 equal to the A2, and the A2 is -2. Just, to show you which equation I used. And then I use this one, which is going to be 4A1 plus 3A3 plus 4 equal to the A4, and the A4 is 6. Okay, so the system that we have to solve are going to be 6A1 plus A3 equal to the -2. Okay, -2, and 4A1 plus 4A1 plus 3A3 plus 4 equal to the 6. Okay, this is going to be the system that we have to solve. And, we can simplify that at 4. Again, elimination method give you the result. 6A1 plus A3 equal to the -2. And this would be 4A1 plus 3A3 equal to a +2. Again, we can multiply the first one by -3 to eliminate the A3. So that gives me -18A1. -18A1 minus 3A, A3 equal to the 6. And the second one is 4A1 plus 3A3 equal to the 2. Okay, you cancel it out. And in this case, you get again -14. Okay, -14A1 equal to 8 this time. Okay, it's going to be equal to the, I didn't make any mistakes. Okay, that's it. Is equal to the 8. So A1 will be -8 over 14, which is a negative, -47. Yes, that's the one. One of them, yes, -47 is correct. So that give you your A1. So the A1 is -47. And then you have to substitute somewhere to get your A3. Okay, you substitute here to get the A3. So it's going to be 6 times -47 plus A3 equal to the -2. So that gives me -24. -24/7 plus A3 equal to the -2. And if you move it to the other side, so that you have -2 plus 24/7. 2 times 7 would be 14, so that gives you 10/7. 10/7 would be the final answer. So, you can use, a metrics to find it. It's a 4x4 matrix, if you can use it can be done. But if you are familiar, quickly we can check it, like echelon form, etc. It can be done. It's not such a big deal. And this is it's very messy, I told you. This is a linear. If you have something quadratic, then you get quite a lot of these, but we give you one to check it. Okay, so we are not done. You have to put back these numbers, get your function, and give us final answer. Okay, so if you remember the function, go back to substitute. So this is going to be your function, x of p. Remember, use those numbers. I'll just give you the result. It's going to be -2t minus 4/7. And the second part would be 6t plus 10/7. Remember our term was A1 plus A2T, then A3 plus A4T. So that's going to be your XP, and eventually the final answer is X is equal to the XC plus XP. Okay, which is officially C1 X1 plus C2 X2 and the XP. These are easy. We can list it if you like, but you don't have to. So the function that you got was very easy function for the K in both cases that you did have. Unless you have to find initial values. That's there's going to be initial condition, then you have to form it exactly. Okay, that's a variation of the undetermined coefficients. There's nothing special, but it takes time. Okay, give a short break. We come back. See if we can do the variation of problem. I'll give you a method which is quite different. But the basic, the foundation is like the one that you did before. It's a nice application.
That's nice of you.
Okay.
That's awesome.
Let's see if anybody remember what was the variation of problem the method
Oh, you're going.
when you did the equation. You remember? Method? Yes.
That was weird. I like that sticker.
Okay. Remember variation of the parameter for finding the XP was
Is it a U?
Did
you use like a U sub almost? That's pretty much all I remember.
For what?
R1 over.
You're good? Yes, you remember the formula. Okay. Now the idea was what? We just solved we solved the homogeneous equation. Remember, we call it XC. In that case, it was C1Y1 plus C2Y2. What we did, we changed the C1 and the C2. They were constant. We changed them to two functions, U1 and U2. Then we forced that combination to be XP. In forcing that combination to be XP, we arrived at two formulas. And that was the variation parameter. You can do the same thing. And it is in your book, in the classic one. And that would be very messy. I used to teach that one. Okay? But there is a short form, really. The river of linear algebra give you a short form. It's the same thing. It's more interesting. Okay? So we're going to do that. In case you see somewhere else, okay, with the U1, U2, you are welcome to use it. Okay? But it takes quite a while to do it. So I'm going to prove this method for you, and then that's it, done. So what is variation of the parameter method for this? Okay, this is it. Variation of a parameter. Okay, that's it. Parameter methods, but we want to use it for the system. That's it. And so the only thing that you need from linear algebra is just the inverse of a 2x2 matrix. So I just remind you, okay, that one. So let's review first or remark. It's the only one that, only thing that we need really. Remark is going to be, so we just recall that if you have that 2x2 matrix, this system that we solve is a system of two equations, two variables. You can do it 3 variables, 4 variables, etc. But we just use the foundation of 2. Okay, this is it. If this is going to be a matrix, then the inverse, A inverse of this matrix is going to be 1 over the determinant of the A. Then the way we are going to write the matrix is going to be, we are going to interchange A and the D, okay? So this is going to be D, and this is going to be A, and we change the sign of the B and the C. So it's going to be D, negative B, and the negative C. Kind of shortcut. We're getting getting the inverse of the matrix A. So it's going to be 1 over the determinant of the A. The determinant of the A would be AD minus BC. And then to get the inverse of this matrix, you interchange the the one on the diagonal, okay, this is it, we change it, and we change the sign of the B and the C. So determinant would be B minus BC, so this is it. So you need to know this formula. It's going to be A inverse is equal to the AD minus BC, and this is going to be D negative B negative CA. Of course, this is going to be true if the determinant of A is not 0. Because if the determinant of A is 0, you cannot use this formula, and A is not going to be invertible. Okay, and we call it inverse because if you multiply by A times A inverse is equal to the A inverse times A, this would be equal to the identity matrix, okay? 1, 0, 0, 1, which is equal to the I. Okay, we need only this one from linear algebra. Now let's see how we're going to design that method of the variation of the parameter. Now, there you go. We have a system, okay, to solve the system, to solve the system. This time it's going to be x prime of t equal to the a times x of t plus f of t. Okay, you know that we have to using, if you like, using variation. Okay, variation of parameters method. So what we have to do, as we did it before, we have to solve the, okay, we have to solve the homogeneous one first, okay? So suppose you solve the homogeneous one and you find your x of c. Remember, x of c of t is going to be what? It's going to be c1 x1 plus c2 x2. This is going to be 1. So suppose this is, of course, is the general solution. Is the general solution of the homogeneous system, okay? General solution of that homogeneous system that we have. Okay, this is going to be general solution of x prime of t equal to the x of t. Here is the one. Now, the way we did it in the ordinary function, we replaced the C1 by U1, C2 by U2. We can do the same thing over here. But we are going to write this one in matrix form. Okay, the matrix form is going to be, note that this form that we have here, you see the x of c is equal to what? Is going to be equal to the C1 x1 plus C2 x2.
Can you move it down, please?
Okay, so this is it. I want to write this in the matrix form. Remember, this is equal to the what? This is going to be C1. X1 is one particular solution, and X1 can be written as what? Is the first component is going to be the X function. We call it X1, and this is going to be Y1. Remember, because your equation, we change it to the matrix form. This is going to be x1 and plus c2. Again, this is another particular solution that we call it x2 and the y2. Okay, this is the case. Now, if you put them together as a matrix, so the result would be what? The result would be something like, you can rewrite this one as matrix x1, x2, y1, y2, okay, times it by c1, c2. Okay, if you multiply together, you get exactly the same one. Because this is c1 x1 plus c2 x2, and you know this is exactly when you multiply together. So what we are going to do is we are going to use a special notation. I'm going to call this one phi of t. So I write it down as phi of t, and instead of the c1 and c2, I'm going to use a constant vector c. Okay, so I repeat it over here again so that you can see it. So the homogeneous solution is going to be x of c is equal to the, okay, this function, which is the phi of t and the c. Okay, this is going to be the case. I repeat it again, where phi of t is just the solution matrix. It's going to be x1, x2, and this is going to be y1, y2, and c is going to be that constant term that you have. Okay, what we did is just those c1, c2, y1, y2 that you write it, we write it down in the matrix form. You see now, this is going to be the solution of the homogeneous one. So what we're going to do is, remember in the case of the linear equation, so you write the general solution of the homogeneous one and you replace the C1 and the C2 by U1 and U2. So there you are. What we are going to do is, this is x of C. I'm going to change it to the x of P by, I keep the YT as is, but I change this constant C, I change it to the vector form. I call it U, which is going to be U1 and U2, and then I work on that one, okay? So I go to the next page and explain it for you, okay? So what we are going to do is the suggestion. The suggestion is going to be define XP to be that phi t is just phi t. And it was C, we change it to the function. That function would be U of t. U of t, and what is this U of t? U of t is going to be a function which defined by U1, U2. Okay, it's like you're replacing the C1 and the C2 by U1, U2 as you did it for the ordinary case. And this is going to be a condensed term. Okay, we define x of p to be what? To be a particular solution. To be a particular solution of what? Of that system that you have. X prime of p equal to the a times x of p, okay, plus f of t. So as we did it with the case of the previous system, case of the equation, remember we substitute that into this equation. Because if you say it's the solution, you must be able to substitute it. Okay, so bring this one here. Bring one this here and substitute it. Okay, so you have to differentiate it. Let's write it down, then I differentiate it. So I have to substitute phi of t, u of t, right? Is equal to the a times what? A times phi of t, u of t. That's f of t. Like this equation, I work on this one. I have the unknown is, what is the unknown? The unknown is going to be that, okay, that u of t that you have. So let's see. Differentiate this one. It's a product of two functions. So we have to apply the, okay, the product rule. Derivative of the first times second, second first. So the derivative of the first one would be phi prime of t times u of t. Last derivative of the second times first would be phi of t times u prime of t, okay? U prime of t, and on the other side, you have same thing. They are all matrices, okay, this is it. That's f of t. Okay, now in the ordinary case, when we substitute, we use the fact that we do have the solution of the homogeneous system. Now, let's see if we can find out. Remember, phi of t was the solution of the homogeneous one. So what was the homogeneous one? Let's just go back, explain it for you. You see, that is going to be the homogeneous one that we have, okay? So if x of t is going to be phi of t, so it must satisfy these conditions that we have. So the situation that you are going to have is going to be the case that we say that phi of t is the solution of the homogeneous system, if you like. Okay, homogeneous system. So what was the homogeneous system? Homogeneous system x prime equal to the what? A times x. So it must satisfy this condition. So this means what? This means in this case, if you substituted y prime of t, phi prime of t is equal to the a times phi of t. Okay. So go back to this equation that we have. Look at this one. I'm going to replace this a times phi of t by what? By phi prime of t. So what is going to be the leftover? The leftover is this. I've already got the phi prime of t ut. That's phi of t u prime of t. Now I replace this one by phi prime of t. So that gives you phi prime of t times u of t plus f of t. Okay, now what will happen? These two are the same. So cancel it out. But it's going to be, remember you are looking for u of t. So what's going to be the leftover? The leftover would be phi of t times u prime of t is equal to the what? Is equal to the f of t. Okay, this is going to be equal to the f of t, but we are looking for u prime. If you have done linear algebra, how do you find the u prime of t from this equation? This matrix equation. If it's in algebra and you want to solve for u prime, what you do?
Divide by,
Yeah, in algebra, we divide by the coefficient of the unknown. In case of the matrices, we don't have the division.
Do you set up a matrix and then slash it with the other side?
do you do like an inverse?
Inverse, yes. And instead of dividing, we multiply both sides by the inverse of the phi of t. This is where you need that inverse. So multiply the phi inverse. You see? This is it. At this part, as we talk about it, okay, sorry, that's the inverse, -1. You know that these two are going to be your I, like identity. So you multiply by u prime, and that give you, okay, that give you prime. So that give you prime of t is equal to the phi inverse of tf. And if you remember, in case of variation parameter of the equation, first we find u1 prime and the u2 prime. Then we integrate to get the u1. This is exactly the same way. So if you want to find the u of t, you have to, okay, you have to integrate. So u of t is going to be integral of phi inverse of t, okay, phi inverse of t, f of t, d of t. That's it. Easy formula, okay, to get it. But if you get this one, then you say that, Matt, what is your x of p? Remember the x of p as we suggested, this was phi of t, u of t. Phi of t, u of t. So the particular solution is going to be, you have to multiply this one by phi of t. Phi of t, integral of phi inverse of t, f of t, d of t. That gives you the particular solution for the, okay, particular solution for your system. And just remind you that what is going to be this phi as we talk about it. Phi is a matrix of those particular solutions that we have at the beginning. It's x1, x2, and the y1 and y2. You see, it's very nice method. You can model this one again by the u1 and the u2, but the resultant formula is quite a lot to memorize.
Can you move it just a little bit to the
And
side?
this would be, so this is it. It's going to be a very, very nice one. So what you do is this. You solve a homogeneous system. When you form a homogeneous system, Remember, you get x1 and the x2. This is x1, this is x2. So you form the phi of t. As soon as you form the y of t, you find the inverse of the phi of t. By the formula that we talked about. You multiply that inverse, there are two matrices. You multiply by phi of t and then you integrate it. And at the end, when you integrate, you have to multiply that matrix again. That integration, because you're integrating a matrix. You know that if you want to integrate the matrix, you have to go inside the matrix and integrate each entry. So it's going to be 2 by 2 matrix. So you have to find 4 integrals if you like. Okay, it's going to be done. It can be done. But most of the time, you may have to use the integration by parts because the solutions are all type of e to the 3t, e to the 2t, etc. to be able to do. But it can be done. I don't think that I would be able to give you an example because it takes a while to write it down. So we will give you an example next time. We are officially done. Okay, this is the last topic, but we have to check this one, a couple of examples. So the examples are going to be the one most